Hi, welcome to my first series of teaching Algebra 1. Today we're looking at 1.1, which is solving simple equations. So today we're going to discuss what is an expression. We're going to learn how to solve simple linear equations using properties of addition and subtraction. We're going to learn about multiplication and division and how we're going to use them to solve equations involving these operations. And we're also going to learn how to solve some equations using real-life problems. In this video, we're only looking at one variable equation, so this is the most simple form of equations we're going to be learning. Today, I'm not discussing two variable equations, only first variable equations. So let's begin talking about expressions. So what is an expression? Well, an expression is something that expresses something. Like if you want to represent a cat by one amount, you'd call it 1x, if the cat is known as x. If you're talking about two cats, then it would be known as 2x. So I'll just write some notes here which will describe what I mean here. Okay, so we know that we're calling a cat x. So if we know that a cat is x, then we know that one cat is 1x, and therefore two cats is 2x. Similarly, 3 cats would equal 3x. So we're just defining something based on something which is not actually a thing that exists in math. We're just using real world examples like objects in our lives. Like your pet may be a cat. If you have 2 cats in your home, then you have 2 x's, because we're calling a cat x. Now, what is an algebraic expression? Well, an algebraic expression is only about algebra and numbers. We're not going to talk about any applications like cats or dogs at your home. It's purely algebra, and it consists of things known as integers, variables, and constants. So what is a variable in an algebraic expression? Well, a variable is something that you don't know. It could be anything. It's variable. You could say a variable is x. It could be y, z, or w. You could also have constants, which per se are just numbers like 4, 6, or 5, or -1. Now, I've included positive and negative numbers, or you could also include 0. So this is a set of integers that you could have in your algebraic expression. Now, coefficients are numbers that multiply to variables. So you could say you multiply 2 with x. This is the multiplication sign, and that's the variable. Or you could write like this in parentheses, so 2 times x. So 2 here is your coefficient, which is being multiplied with the variable. You can also write the coefficient like this. You can multiply a number with a dot. That's the multiplication sign. You represent it with a dot, and you multiply it with x. So this is the coefficient of x, which is 2, and here it's also 2, and here it's also 2, because they're all multiplying to the same variable. So now that we know what expressions are, and we know what variables, constants, and coefficients are, we have to find out what an equation is. An equation is basically an equality. It's what defines what an expression equals to another expression. So let's say we have 2x. This is one expression. You could come up with another expression which may have constants and coefficients, or even different degrees of power with the x. You could have 2x squared, which is just 2x times x. You could have 6 plus x. You could have 8 minus x. You could have anything for an expression. What an equation is, you have to have an equal sign. An equal sign, you place it between expressions, and then you form an equation. So what that does is say 2x equals 2x squared. You know that 2x equals 2x squared. So that forms an equation. This is an equation because we're saying that 6 plus x is some value which is equal to 8 minus x. So now that we know what equations are, let's go ahead and solve some equations. Let's try solving this equation that we just wrote, which is 6 plus x equals 8 minus x. This is a hard one, so let's try with an easier one. Let's say you have 2x minus 6 equals 0. Or you may want to solve, say, 2x equals 1, or x equals 1. Well, this one's the easiest equation, so we just know that 1 equals 1. Now, this is just the most simple property of equality, where if you define something equals something with no other operations in between, then you could just say that x is equal to the value that you're equaling it to. Therefore, 1 is equal to 1. So what about harder equations? Well, we have to know some properties of equalities, and some of these are the addition property of equality, the subtraction property of equality, the multiplication property of equality, and the division property of equality. First, I'll go through addition property and the subtraction properties. So what does the addition property of equality say? Well, it says that if you define that one variable x equals another variable y, then you know that if you add a variable, say b, or some value b, to x, then the other side of the equation will also be y plus b. Hence, it makes the equation equal and there's no contradictions in the equation. What about the subtraction property? Well, if you equal x equals y, then if you subtract something on one side, then you must subtract it from the other side as well. So if you subtract b from x, so it becomes x minus b, then you must do y minus b on the other side. Therefore, these two are equal and they're balanced. Now, here are the two final properties that are multiplication property and the division property. Multiplication property is that if you multiply some variable or constant with another variable, say x, and you let x equal y, then y should also be multiplied by b to give yb, or y times b. Therefore, x times b is equal to y times b. And this makes the equation equal to this part. So, what's the division property? Well, again, you define x equals y, and because of its division, you divide it with b. So x over b equals y over b. And if you multiply each side by b, you end up with the same equation as well. So you know that these properties are all true and they're equal. Okay, so now that we know the properties of equality that are addition, subtraction, multiplication, and division, we can use them to solve these equations that I have here. Each of these is distinctive of each of the equality properties, so let's look at this one. We have n plus 3 equals minus 7, so we know that n plus 3 should equal minus 7. So how can we reduce this equation so that we have n left on this side? Well, we could do subtraction property, which is subtracting from each side. You could do subtraction of minus 3 from each side, and that will give you, this one's going to cancel out, and you get minus 7 minus 3. So that gives you negative 10. Therefore, you know that n equals minus 10. And so minus 10 plus 3 does equal negative 7, so you know that this is true. Let's look at number 2. We have pi x equals 2 pi. So we know that pi is a coefficient of x. As we mentioned last time, a coefficient is a constant that multiplies to another variable. And here we have 2 multiplying to pi, so 2 is the constant here. So we want to solve for x. So what do you think we should do? I think we should divide by pi from each side by using the division property. So if we divide pi from each side, then we get, you divide it by pi from here and you do the same here. Well, the pi's cancel out and so do they here. And we end up with x equals 2. Now let's look at number 3, which says y over 3 equals minus 6. Well, to solve this question, we know that we're dividing y with 3. So in order to separate y from this part, we have to multiply the whole equation on both sides with 3. So what we're doing is we're using the multiplication property of equality by multiplying 3 on each side. So that gives you 3 times y over 3 equaling 3 times minus 6. So I've multiplied 3 on each side to make sure that this whole equation equals this when we reverse the operation. So the 3's cancel out, and here nothing cancels out, and we're left with y equals 3 times negative 6. Well, 6 times 3 is 18, and 18 times that negative sign gives that minus 18. And this is our answer. Let's verify if that actually is our answer. So if you put that number back into y, so if you do minus 18 over 3, then you get 18 over 3, which is 6, and times that minus sign, which gives minus 6. So we know that this equation is correct. What about number 4? Well, we have x minus 4 equals 0.5. So there's only one way that we can get rid of that minus 4 from this side, and we know that's the addition property of equality. Why is it the addition property? Well, it's because we have to get rid of x by doing the reverse of this minus sign, and that is by doing the addition of 4 on each side. And if we do that, minus 4 plus 4, it cancels out, and we get x alone here. And so 0.5 plus 4 is equal to 4.5, and therefore x is equal to 4.5. Now let's actually check if this is the answer by putting it back into the original equation. So if we put 4.5 in x and you do 4.5 minus 4, then we know we get 0.5 for the answer, and we know that this is correct. Let's look at this final problem. It's an application of what we have learned. Usain Bolt, I think we know who that is. He can run 200 meters in 19.32 seconds. And the question is asking, formulate an equation and find Bolt's average speed to the nearest 100th place. Well, let's look at this question again. We're told that the distance that Bolt ran is 200 meters, so we know that the distance he ran is 200 meters. And we know that the time he ran this in is equal to 19.32 seconds. Now we're finding his average speed in meters per second, so we know that the units are equal to meters per second. Well, to find the average speed, we know that the total distance is 200 meters, so we know that the average speed is equal to 200 meters. That's the total distance that he ran over the total time it took to cover that distance, and that is 19.32 seconds. And if we put that in the calculator, we get $10.35. Now it's asking to the nearest hundredths place, so let's look again. It's 10.351. 1 is not close to 5, so we don't round it to the next hundredths place, so it remains at 10.35. And this is the answer, but make sure to include your units. So the answer is 10.35 meters per second. And this is it for this question. Now this is it for 1.1, solving simple equations. In the next lesson, I'll teach you 1.2, which is on solving multi-step linear equations by using inverse operations. We're also going to learn how to solve multi-step equations to solve real-life problems. And we might also use unit analysis to model real-life problems. I'll see you in the next video, and leave a like and provide some feedback so I can make my videos better. Thanks.